Unfortunately, we've lost yet another class to the weather. So for graphing sine functions, I'm going to break this material up into probably 3 videos so nobody gets too bored listening to me all at once. So looking at graphing the sine function, we've already looked at the information for sine function in terms of our various angles, which instead of calling theta now, we're calling x, but remember, these are our thetas, our angles, and then the ratios that are the trig function sine of these angles. So in the first quarter, which here from 0 to pi over 2 or 0 to 90 degrees, our sine starts at 0, then we go to 1/2, then we go to square root 3 over 2, then we go to 1. So we can see in the first quadrant from 0 to pi over 2, our trig functions sine are increasing from 0 to 1. We're going to look at this information on the graph now. So just below here, we can see the same information, but in a picture in a graph. At 0, sine of 0, 0. At pi over 2, sine is 1. And at pi over 6 and pi over 3, and we don't have 45, but in between these two would be 45 degrees pi over 4, and our ratio would be radical 2 over 2. We can see that we are increasing. So same information we've looked at, but now in a graph. Continuing on to the second quadrant. So here we're going from 90 degrees to pi in Q2, and we can see that our ratios now are decreasing. We're going from 1 to 0. Same ratios, radical 3 over 2, 1/2, and then of course radical 2 over 2 would be in here. And looking at this in the graph from pi over 2 to pi, we can see this decrease from 1 to 0. Here at 2 pi over 3, we're at radical 3 over 2. And then we would decrease to radical 2 over 2 and then 1/2. So we can see Q1 and Q2 are sine values are positive, which we know sine is positive in Q1 and Q2. So let's move on now to Q3 and Q4. In Q3, so now we're looking between pi, 180 degrees, and 3 pi over 2, or 270 degrees. We can see that we continue to decrease from 0 now to -1. So we go from 0, -1/2, radical 3 over 2, and then -1. And again, on the picture from pi to 3 pi over 2, we can see this decrease from 0 to -1. Last but not least, in Q4, looking at the graph here, we can see that we started this relative minimum, if you will, of -1, and we're going to increase back to 0 again. And looking at our chart, we can see we start at -1 at 3 pi over 2 or 270, and then we increase negative radical 3 over 2, -1/2, and then back to 0 at 2 pi. So let's take a look at this graph here. There are what we're going to call 5 key points here, and these key points are our x-intercepts, which in the case of our sine function, we have 3 x-intercepts. So here are 1, 2, 3 of our key values. Then another key value is going to be at any maximum, relative max that we have, which in this case is 1 and occurs at pi over 2. And then minimum here, which is -1, and this occurs at 3 pi over 2 or 270. So when we graph our sine function, we're going to be looking at graphing 5 key values, 3 intercepts, 1 max, and 1 min, and then we're going to sketch in the graph to connect these dots. We could, and in your project, we could calculate the values for pi over 6, pi over 4, pi over 3, and calculate many more values to sketch our graph. But in our class, what we're going to do, other than your project, is focus on the 5 key values and then sketching the graph from there. So before we move on from this, let's look at some ideas we've already talked about. The domain. As we've already said, the domain of sine is negative infinity to positive infinity, and this graph shows that. Remember, domain in this case has to do with all our angle values that we are putting into our trig function, and we can see, I mean, here we stop at 0, but we would go on forever in the negative direction. In terms of our range, again, we've already talked about this, but the range of your basic sine function is -1 and 1 inclusive. From this bit of the graph we've done here, we see that we get as high as 1, but we don't go above it, so we're limited by 1 for a max, and then we get as low as -1, but we don't go below that, so we are limited by -1 as a minimum. Also a little FYI reminder that sine of x is an odd function, and odd functions have symmetry with the origin. So we've stopped here, but if we were to continue this, and we will, we'll see that graphically that origin with the origin. And last but not least, period. Period we defined before as what the time it takes or the amount it takes to go through one complete cycle of hitting all the values. So for sine, the normal period is 2 pi. So this gives us an idea of what the sine function would look like when we graph it using XY coordinates. So now let's take a look at some other information regarding our graph. We're going to start out and then we're going to build on this, but starting with a pretty basic equation, y is equal to a sine b. Let's take a look at this information. A is what we call the amplitude, and A is the absolute, the amplitude is the absolute value of A. And what A represents here, so this value here would be A, and this value here would be negative A. A is this distance here. A is the distance from the max to, in this case, our x-axis, and A is also the same distance here from the minimum to our x-axis. So amplitude is A, and it's the absolute value of whatever information's here. So the amplitude is a distance. Period is defined as 2 pi over b. So for sine, we're going to be able to find the period by taking 2 pi and dividing it by whatever information is in front of the x here. Now, remember from pre-calc, these A and B represent horizontal and vertical stretches and shifts. This A, which is out in front, would be a vertical shift, which you're going to see. It's going to impact, going to stretch our function like this or shrink it down. And then B is a horizontal shift, which will stretch our trig function, either stretch it or shrink it along the x-axis. So let's take a look at the steps that we are going to use, and then we'll go ahead and graph one. So in order to graph a sine function, we're going to have to identify information given. Amplitude and period. So very important. We're going to have to define what the amplitude and the period are, I should say. Next, we're going to find 5 key points. So we're going to find those 5 key x values where we're going to have our 3 intercepts and then the max and the min. So we're going to find those x values. And the way we're going to do that is we're going to take our period and we're going to divide it by 4. Next, we're going to find the sine values that go with these 5 key points. And that's going to be pretty straightforward. We already know what they are. They're going to be 0, 0, 0. We're going to have 3 zeros. And then we are going to have a 1 and a -1.